Hello guys, what's up? This is Mortaza. Welcome to a coder's journey. This is the next video in this playlist where I am talking about the most important principles in software development. These are the principles that, when acquired, will not only help you to become a better programmer in general, but also will help you to land your dream job, because I know from experience that these principles are more often than not asked about in job interviews. So if you have not already watched the previous videos in this playlist, I highly suggest that you guys do watch them, because so far we have talked about two very important principles, right? So the SRP and the OCP. And then come back and watch this video. And generally there is not a specific order to watch these videos in this playlist, but I want you guys to watch all of them, right? So in this video, I'm going to talk about the Liskov Substitution Principle, right? I'm going to tell you guys what this principle is all about, and then we're going to talk about the benefits of adhering to this principle. So let's get started, shall we? The first part is the definition, right, of the Liskov Substitution Principle, or LSP. So this principle means or dictates that calling code should seamlessly use either a base class or a derived class instance or object without explicit knowledge or a special handling. It's a mouthful, right? So let's talk about this a little bit to kind of make the topic or the concept, easier to understand, right? So calling code means the code that is calling another method or function. So we have calling code and a code that is being called, which is sometimes referred to as callee. So callee is the code which is being called, like a method or a function. And caller or calling code means the function or the line of code which is calling that target method, that callee, right? So calling method or calling code should seamlessly means without being aware of it, right? So without needing to check something, right? Because in the next paragraphs, I'm gonna, draw a scenario which I think you have all familiar with. So just bear with me. So calling code seamlessly use an instance of a base class or a derived class, right? Without being aware of it, or without being forced to check whether this object is an instance of a base class or a derived class. So this means Liskov substitution. So it kind of means that your code should be able to work with an instance of a base class or a derived class without being aware of it, without being forced to check whether this object comes from the base class or the derived class. Let me give you guys an example. So suppose that we want to implement the concept of a square as well as a rectangle, right? So a square and a rectangle are different in terms of the length of their sides, right? So a square means that the length of each side is equal. So a square has 4 sides, each of which has the same length. So this is the definition of a square, right? But a rectangle is different. So a rectangle has 4 sides like a square, but the difference is that for a rectangle, 2 sides have the same length and the other 2 sides are of different lengths. So this is the difference between a square and a rectangle, right? So What happens if you implement the concept of a square and rectangle as kind of a, inheritance hierarchy? So this will pose a challenge if a square is derived from rectangle or vice versa. Why? So in your code bases, I think I have done it before. That, for example, I wanted to implement these two classes, and I thought to myself, so probably a rectangle should be a square where all the sides have the same length, or a square is probably a rectangle where two of the sides have the same length, the other two have another, length. This is a bad idea. You shouldn't implement a rectangle as the base class and then a square, a derived class, or vice versa. And I'm going to tell you why. To address this, introducing an abstraction like an interface. So you're going to declare an interface called iShape with methods like calculate area, which can help you to calculate the area of different classes, whether a rectangle or a square. So I'm not going to choose a square or rectangle as the base class and the other one as the derived class. What I am going to do is to declare an interface on an abstract class called shape or iShape. And then that interface will have a method called calculate area, and then different shapes like a square, triangle, rectangle, oval, so on and so forth will implement that iShape interface, and then they will implement the calculate area the way they want, right? So LSP or Liskov substitution helps us to facilitate code use. So by implementing LSP, we can use our code much more easily. But it can also serve as a tool to detect potential issues in object-oriented models. Let me give you an example. I know that you have done this before. I have done it many times. I have a method, right? And in the body of the method, I need to check a parameter that the method takes in, and based on the type of that parameter, I do different things. So I say if the incoming parameter is of type square, do this. Calculate the area like this. If the incoming parameter is of type rectangle, calculate the area like this. This is more often than not a sign that you are violating the LSP principle. So don't do that, right? So don't do that. And whenever you are, writing a method where you are forced to check the type of an incoming parameter, and based on that type, you are doing different things, this means that you are violating the LSP principle. So as I told you, your code should be able to seamlessly, this is the key word, seamlessly be able to work with either a base class, an instance of the base class, or an instance of the derived class. So whenever you are checking this in a switch statement or if conditional, it means that your code is not working with those instances seamlessly. You are explicitly checking the type of the object, right? So this is very important. As I told you, seamlessly is the key word here. Now, adhering to LSP simplifies calling code, as I told you, promoting generic functionality across any class or subclass. So calculate area will be a generic behavior. So it will calculate the area of an object without us being have to check the type of the parameter, right? As it says here, without requiring additional conditional logic. So conditional logic simply means if statements or switch statements. So stick to LSP principle. I know that you have written code where based on the type of a parameter you do different things. I know I have done it before, and I see it every now and then in different code bases. And this is a red flag. This is a sign that you guys are not adhering to the LSP principle. Think about those inheritance hierarchies, double check. As I told you, the example, of a square and a rectangle. Sometimes because we want to reduce code, duplication, we go for the, inheritance and so on, but that is not the best route to go, right? So separating those ideas and then implementing an abstraction for these two different classes would be the best idea. Thank you so much, guys, for sticking to the very end. I hope you have enjoyed watching this video. If that's the case, make sure you subscribe to A Coder's Journey. Give this video a thumbs up. Support the channel. That will help me, stay motivated to create more videos for you guys. And stay around. In the next video, I'm gonna talk about the most important, one of the other most important principles, interface segregation. So till later, stay awesome and bye-bye.